Envision a colossal structure crafted from steel and concrete, carving its way through the core of a mountainous expanse, engulfing entire trains and then releasing them on the opposite end in a faraway destination. This isn't a product of imaginative fiction. Rather, it's the tangible existence of the most extended railway tunnel globally, known as the Gotthard Base Tunnel located in Switzerland. A massive endeavor with a price tag exceeding 120 billion euros has transformed the European landscape significantly. Behold the most extensive railway tunnel ever constructed, traversing the formidable St. Gotthard Massif in the Swiss Alps. This engineering marvel aims to enhance connectivity between Switzerland and Italy through a high-speed rail connection, while alleviating truck congestion by diverting a portion of road freight onto the rail network. However, the journey of creating this colossal tunnel was an arduous and protracted undertaking. In today's script, we'll be unraveling the technical obstacles that had to be surmounted to accomplish this remarkable feat of engineering. The Gotthard Basis Tunnel, situated between Erstfeld and Bodio, is a major project that started construction in the 1990s. It officially opened for commercial traffic on December 11, 2016, cutting through a massive rock wall over 3,600 meters high along a length of more than 57 kilometers. As of now, it holds the record as the world's longest railway tunnel, surpassing the well-known Channel Tunnel by over 6 kilometers. Construction, initiated in 1994, involved around 2,400 people working continuously to progress the project. A collaborative effort from workers, engineers, surveyors, and various other trades was crucial for this exceptional tunnel. Unlike the previous railway tunnel positioned at the summit of the massive structure, the new tunnel is at the base, providing the advantage of a nearly straight path with a minimal gradient ranging from 300 to 560 meters. With a maximum gradient of 12 meters per kilometer, significantly less than the historic line's 26 meters per kilometer, this change is significant. It eliminates the need for freight trains to navigate mountain climbs, twists, and turns, eliminating the requirement for an extra locomotive to push the convoy. Consequently, the new Gotthard Basis Tunnel can cut energy consumption in half, even with longer and heavier trains, resulting in a 45-minute time saving on the journey between Zurich and Lugano. In the present day, the Gotthard Tunnel, steeped in historical significance, accommodates 260 freight trains, reaching speeds of 160 kilometers per hour. This marks a contrast from the past when 180 trains traversed this remarkable tunnel. In 1882, the inauguration of the old railway tunnel, spanning nearly 15 kilometers and descending 1,000 meters below the summit, represented a remarkable technological achievement, earning it the distinction of being the world's longest tunnel at that time. The advancement in travel time is attributed to the implementation of a high-speed line. Employing the revolutionary dynamite patented by Alfred Nobel in 1867, the tunnel was excavated from both ends. While the historical tunnel serves as a backup in case of high-speed line closures due to incidents or repairs, its benefits extend beyond freight to include passengers. Since the completion of the 15-kilometer extension tunnel in 2020, the high-speed line connecting Milan and Zurich has realized a time savings of nearly 1 hour. The tunnel has a maximum speed limit of 200 kilometers per hour, surpassing the Eurostar speed limit in the Channel Tunnel by 40 kilometers per hour. Let's set aside the discussion of trains for now and focus on the technological features of this enormous tunnel. The Gotthard Basis Tunnel comprises 2 parallel tubes, each boasting a diameter exceeding 8 meters and positioned approximately 40 meters apart. This tunnel is designed with utmost security in mind. Each tube hosts a one-way track, and unlike the Channel Tunnel, there is no separate tube for evacuating passengers in case of accidents, breakdowns, or fires. Instead, transverse galleries interconnect the 2 tubes at intervals of 3 to 5 meters, providing a means for stranded passengers to access the neighboring tube. In case of any issues, the tunnel incorporates 2 emergency stop stations. These stations tubes feature smoke extraction chimneys and robust ventilation systems to avert potential disasters in case of a fire in one of the tubes. The safety mechanisms create an excess pressure in the second tube, preventing the infiltration of smoke and allowing passengers to escape to fresh air. Additionally, the stations house 2 exchange rail diagonals, facilitating the transition of trains from one tube to the other when necessary, such as during track maintenance. These measures ensure not only safety, but also operational flexibility. The agricultural industry stands as one of the primary beneficiaries of the world's longest tunnel. With streamlined freight transport, perishable goods, including fruits, vegetables, and other time-sensitive products, now traverse vast distances with unprecedented efficiency. The tunnel's reduced transit times have mitigated spoilage risks and allowed farmers to expand their markets, reaching consumers across regions with fresh produce that retains its quality. Manufacturing processes have undergone a revolutionary shift thanks to the tunnel's transformative impact on freight transport. Raw materials and finished goods now navigate the subterranean passage swiftly, facilitating just-in-time production strategies. Factories can maintain leaner inventories, reducing warehousing costs and enhancing overall operational efficiency. As a result, manufacturers can respond more agilely to market demands, ultimately fostering economic growth in the manufacturing sector. The tunnel's influence extends to the energy sector, where the transport of bulky and heavy equipment, including components for renewable energy projects, has been significantly streamlined. Wind turbine parts, solar panels, and other large-scale energy infrastructure components can now traverse the tunnel with ease, expediting project timelines and reducing costs associated with transportation. This newfound efficiency has played a pivotal role in accelerating the adoption of sustainable energy solutions. The interconnected nature of global trade has been further solidified by the world's longest tunnel. The efficient movement of freight has contributed to a more seamless exchange of goods on an international scale. As a result, economies around the world have witnessed an uptick in cross-border trade, fostering economic interdependence and collaboration among nations. As industries continue to leverage the enhanced efficiency and connectivity provided by this engineering marvel, the impact ripples across the global economic spectrum, propelling us into an era where the seamless movement of goods is no longer an aspiration, but a tangible reality. In the monumental saga of how the world's longest tunnel reshaped freight transport, the narrative would be incomplete without delving into the intricate details of overcoming geological challenges. The construction of this tunnel was a triumph over nature's formidable obstacles, each demanding a unique engineering solution. Here's an in-depth exploration of the hurdles faced and conquered in the realm of geology. Geological surveys and analysis. Before breaking ground, exhaustive geological surveys were conducted to understand the diverse rock formations along the tunnel's path. Engineers meticulously analyzed the composition, density, and stability of various rock types, from solid granite to softer sedimentary layers. This comprehensive understanding allowed for precise tunneling methodologies tailored to each specific geological condition. Tunnel boring technology. Advanced tunnel boring machines equipped with customizable drilling heads were employed to adapt to different rock types. The tunneling process involved adjusting the cutting parameters based on real-time geological data, ensuring efficient progress while minimizing wear and tear on the equipment. Aquifer mapping. The tunnel traversed regions with varying water tables and aquifer systems. To mitigate water ingress, aquifer mapping was conducted to identify potential water flow paths. Reinforcement measures, such as grouting and waterproofing technologies, were employed strategically to fortify the tunnel against water pressure and prevent any compromise to the freight transport infrastructure. tunnel lining materials. Specialized tunnel lining materials with water-resistant properties were used to create a protective barrier against water infiltration. The selection of these materials was guided by a thorough understanding of the hydrogeological conditions, ensuring the longevity and structural integrity of the tunnel under varying water pressures. Seismic hazard assessment. Given the tunnel's geographical span, seismic activity was a significant concern. Engineers conducted rigorous seismic hazard assessments to gauge potential risks and design the tunnel with seismic resilience in mind. This involved implementing flexible structural elements, shock absorbers, and base isolators to dissipate seismic energy and protect the tunnel from damage during earthquakes. Real-time monitoring systems. To enhance safety, real-time seismic monitoring systems were installed throughout the tunnel. These systems could detect even minor seismic events, triggering automated safety protocols and, if necessary, halting freight transport temporarily to ensure the well-being of both infrastructure and personnel. In the face of such geological challenges, the construction of the world's longest tunnel became a testament to human ingenuity and technological prowess. The meticulous approach to understanding and overcoming diverse rock formations, water pressure intricacies, and seismic threats has not only facilitated efficient freight transport, but has also set a precedent for future tunneling endeavors worldwide. The legacy of this engineering marvel extends beyond its physical structure, echoing the triumph of conquering nature's obstacles in the pursuit of redefining global freight transport. As the world's longest tunnel bore through mountains and conquered the depths of the earth, it not only transformed the physical landscape, but also reshaped the very essence of freight transport. This tunnel isn't just a hole in the ground. It's like a magic thread tying faraway lands together. The rhythm of trains in the dark echoes a new way of doing things. It's not just about shipping stuff. It's about countries working together, sharing ideas, and making things better for everyone. Stay updated on construction news by liking and subscribing. Thanks for watching.